The Golden Gate Bridge is one of the most recognizable landmarks in the world, known for its stunning design and location spanning the Golden Gate Strait in San Francisco, California. The bridge was designed by Joseph Strauss and was constructed from 1933 to 1937, with its official opening on May 27, 1937. Here is a detailed biography of the Golden Gate Bridge. Design and construction. The idea for the Golden Gate Bridge was conceived in the early 20th century, with many people calling for a bridge to connect San Francisco to Marin County. Joseph Strauss, an engineer and poet, became obsessed with the idea and developed a preliminary design in 1917. Strauss faced many challenges in getting the bridge approved and financed, but eventually succeeded in 1930 when the Golden Gate Bridge and Highway District was formed. Construction on the bridge began in 1933, with a team of more than 10,000 workers involved in the project. Strauss chose Irving Morrow, an architect, to design the bridge's distinctive Art Deco style. The bridge's signature orange color was chosen to increase visibility in the foggy conditions of the strait. The bridge's main cables were made up of more than 80,000 miles of wire, and the two main towers were built to a height of 746 feet, making them the tallest structures in San Francisco at the time. The bridge's roadway, which is 1.7 miles long, is supported by two main cables, each consisting of 27,572 strands of wire. Opening and reception. The Golden Gate Bridge was opened to the public on May 27, 1937, with a ceremony attended by more than 200,000 people. The bridge was an instant success, attracting tourists from all over the world who marveled at its beauty and engineering. The bridge's opening was a major event, with President Franklin D. Roosevelt sending a message of congratulations and the U.S. Navy staging a flyover. In the years following its opening, the Golden Gate Bridge became an icon of American engineering and a symbol of San Francisco. It has been featured in countless movies, TV shows, and works of art, and has become one of the most photographed structures in the world. Maintenance and upgrades. Over the years, the Golden Gate Bridge has undergone several major maintenance and upgrade projects to ensure its continued safety and functionality. In 1950, a pedestrian walkway was added to the bridge, allowing visitors to walk across the span and enjoy panoramic views of San Francisco Bay. In 1986, a seismic retrofit project was launched to strengthen the bridge against earthquakes. The project involved the installation of new earthquake-resistant components and the reinforcement of existing ones, and was completed in 1995 at a cost of $660 million. In recent years, the Golden Gate Bridge has also undergone several aesthetic upgrades, including the installation of energy-efficient LED lighting in 2013 and the addition of a new public plaza on the bridge's south end in 2019. Legacy. The Golden Gate Bridge has left an indelible mark on the world of engineering and design, and has become a symbol of San Francisco and the United States. It has been recognized as one of the 7 wonders of the modern world, and has been designated a National Historic Landmark by the U.S. Department of the Interior. Beyond its engineering and design achievements, the Golden Gate Bridge has also become an important cultural and social landmark, with many people using the bridge as a site for protests, celebrations, and personal milestones. It continues to inspire awe and admiration in visitors from around the world, and remains one of the most iconic structures of the modern era. The engineering behind the Golden Gate Bridge is truly impressive and involved innovative solutions to complex problems. Here are some of the key engineering features of the bridge. Suspension design. The Golden Gate Bridge is a suspension bridge, which means that the roadway is suspended from two main cables that run between two towers. The main cables are anchored to massive concrete blocks on either end of the bridge and are held in place by enormous steel anchorages. Tower design. The two towers of the bridge are massive structures that are 746 feet tall. They were designed to be slender and aerodynamic, with a unique Art Deco style. To support the weight of the bridge and withstand strong winds, the towers were built with a tapering design that is wider at the bottom and narrower at the top. Cable design. The main cables of the bridge are made up of 27,572 strands of wire, each with a diameter of 0.2 inches. The individual strands were twisted together into larger strands, which were then twisted together to form the main cables. The cables were then coated with a protective layer of grease to prevent corrosion. Anchorages. The bridge's anchorages are massive concrete blocks that weigh over 60,000 tons each. They were designed to resist the force of the main cables, which pull on them with a force of up to 80,000 tons. Wind resistance. The Golden Gate Bridge was designed to withstand strong winds, which are common in the strait. The bridge's deck is designed to be flexible, allowing it to move with the wind and reducing the risk of damage. The bridge also features wind shear towers, which are shorter towers located at the end of the main cables that help to reduce the impact of wind gusts. Seismic retrofit. In the 1980s, the bridge underwent a seismic retrofit project to make it more resistant to earthquakes. The retrofit involved the installation of new seismic components, such as shock absorbers and dampers, to help absorb and dissipate earthquake energy. Overall, the engineering behind the Golden Gate Bridge was a remarkable achievement that required innovative solutions to overcome the many challenges of building a bridge across a large and turbulent body of water. The end.